Welcome back. One of our goals this year was to introduce you to the world of wireless, taking it a little bit further. You probably noticed the name change from last year. Before, it's always been called Wi-Fi Trek, but now it's the Wireless Technology Forum, or WTF. Remember, hashtag WTF20. And what we wanted to do was begin to expose you to some of the rest of the wireless world. And there are a lot of options out there. We've heard about Bluetooth, we've heard about ISA 100.11a, we've heard about wireless HART, we've heard about a lot of different technologies related to wireless communications. And we're going to go a little bit deeper and a little bit further now as we look at ultra-wideband, or UWB, and see what it might be used for and how it might be beneficial. And for this, we have Peter with us to give us this information. So Peter, it's all yours.
Hi, my name is Peter, and today I'll talk about ultra-wideband. Before I jump to the presentation, I would like to thank the CWNP very much for giving me the opportunity to speak and for selecting me as a speaker. So thank you very much, and I hope you guys will like the presentation. I named the presentation Real-Time Tracking That Actually Works. The reason why actually comes from UC's presentation earlier in the year at the WLPC, where he talked a lot about Wi-Fi RTLS and about some of the fails that he had with real-time tracking. So it kind of inspired the name. Just quick introduction about me. I'm a radio engineer major. I'm currently working in a sales role, but I have a technical background in radio and mainly in ultra-wideband. So that's my main focus. Currently, I'm working in a company called Savio, which makes a real-time tracking system based on ultra-wideband. Now, regarding the picture on the right side, when I saw on Twitter the feed about the speakers being announced for CWNP, I saw that one person wanted to present in a Scottish kilt. So I thought that I myself would bring a traditional Czech folklore costume to the conference because I'm from Czech Republic. So unfortunately, conference is virtual, so I at least wanted to show you a little sneak peek of how it may have looked like. So maybe next year, who knows? But let's jump to the presentation itself. Regarding agenda, I will first start with a little bit of a theory. I'll make a quick introduction to ultra-wideband in general. I'll tell you where ultra-wideband is today in terms of standardization and markets and so on. And we'll look a little bit into the future. And then the second half is a little bit more practical. And I'll show some project examples and how a project is typically delivered with ultra-wideband. And at the end, there will be some additional materials for those of you who will be interested in more. So let's start with the basic question. What actually is ultra-wideband? Some of you may have heard that Verizon's 5G network is called ultra-wideband service. So no, this is not the ultra-wideband that we'll be talking about today. I don't know why they picked the name, probably like the name of it or the sound of it, but this is a very different ultra-wideband. It's just the marketing name that they gave for their network. Today we'll talk about ultra-wideband as a real-time tracking technology. What it actually is, or where it fits, kind of is shown on this slide. So why do we need indoor tracking systems in general? Is that indoors we cannot use satellite-based systems like GPS or GLONASS or any other GNSS systems because the signal doesn't penetrate inside. So we use technologies like Wi-Fi, Bluetooth, or ultra-wideband, which is the latest addition to the mix, to do real-time tracking indoors. Now, ultra-wideband is not a new technology. It has been around for a couple of years now, but unfortunately, not many people know about that. So, for example, when you watch NFL, every NFL game uses ultra-wideband to track the players, to measure their performance, and also to provide valuable statistics to the media. So, currently almost 3,000 players are being tracked using ultra-wideband to provide valuable statistics. Or more than 100 aircraft spray painters use ultra-wideband to increase security on a workplace. So this is a very common technology in that environment. And what I find most interesting or exciting is that the Jaguar Land Rover uses ultra-wideband for keyless entry. You may have heard about the so-called relay attacks, where somebody can hijack the wireless signal coming from your car key to actually, hijack your car or steal your car using this hijacked signal. So ultra-wideband kind of prevents that by actually making sure you're really standing next to the car while opening it. So as already mentioned, ultra-wideband falls under radio indoor location tracking technologies. One of the way of looking at these technologies is splitting them into two major parts. One is radio-based technologies, another is like optical and sound-based technologies. So ultrasound, infrared, or laser-based technologies. And in radio, you have traditional Bluetooth, Wi-Fi, passive and active RFID, and ultra-wideband as a kind of a fourth option. Now, in terms of the technology itself, the radio, FCC really back in the day allowed quite a big band for unlicensed use. It spans all the way from 3 to 10 gigahertz, although chips practically used are typically using 3 to 7 gigahertz most of the time. Channel bandwidth for ultra-wideband is 500 megahertz, and effectively there are like 3 channels that you can use based on regulations globally. It's channel 2, which sits at 4 gigahertz, channel 5, which sits at 6.5 gigahertz, and channel 9, which is kind of a new channel that's being used right now, and that one sits at 8 gigahertz. Power level is really at the noise floor, so it's very similar to, for example, 3G CDMA technology. So unless you really have ultra-wideband equipment, you cannot really identify the signal because of the very low transmission power and the very wide spectrum. What is very important that the positioning or measurement of the distance is based on so-called timestamps, not RSSI, received signal strengths, which kind of gives it very high precision of positioning in the level of decimeters or feet for American audience. Now, as any technology, it has its pros and cons. So the pros of ultra-wideband in terms of real-time tracking is definitely the high precision, high fidelity, high durability in harsh environments. Harsh environment would be a warehouse, basically any place with lots of metals inside, limited line of sight between the devices, and a high number of location updates. You really have for a single locator or tag, you really have up to 100 location updates per second, which is a lot. And last very good kind of advantage of the technology is that it doesn't, because of that low transmission power, really the noise floor, doesn't interfere with existing technology. So even if you have already Wi-Fi infrastructure in place or RFID, for example, ultra-wideband does not interfere with that. From the cons, definitely one of the main things is that ultra-wideband requires infrastructure, which means that typically every anchor is a fixed device that you install, something like an access point, requires typically an Ethernet cable. And the tags are not as cheap as, for example, Bluetooth location tags, because the price of a Bluetooth chip is much lower than an ultra-wideband chips just because of the volumes. Just to kind of give you an idea about the performance, this is an example from an industrial plant. The area outlined by those 4 green anchors is 20 times 40 meters. And here you can see the very high update rates and the very high precision of location. So here we have 10 positions per second or 100 millisecond refresh rate, and you can see how smooth the tracking is, even in the environment that's shown on the right side with lots of metals. Now, every location system has this feature which is called zones, virtual zones. And that's the biggest advantage of a location system in general. Typically, customers are not that interested in the position itself, but rather in the zones. So for example, how long a person has spent in a given zone, or how long a given asset, or is that person allowed to go into that zone, and so on. So zones allow all of these use cases, and it's the main feature in all location systems. Now, I tried to make a simple comparison between ultra-wideband and a narrow-based system, based, for example, on BLE or Wi-Fi. So imagine you have two, for example, here metal pallets that you're tracking. On the left side, you have the narrowband technology with the location precision of, let's say, 3 meters. And on the right side, you have ultra-wideband with 1 foot accuracy or 30 centimeters. Now, if you have these zones really stacked next to each other, what effectively happens is that with the narrowband technology, you will see something like this. So tag really moving around the actual position. In ultra-wideband, you will see those same kind of jumps, but the radius will be much smaller, on those 30 centimeters. What happens on the back end is that with the narrowband system, you're getting a lot of false readings if you have the zones really next to each other, because the accuracy really is not enough for such a use case. But if you have that high fidelity, you know exactly that that asset has been in the right zone and with very high confidence. So let's look a little bit under the hood. So how do you actually calculate position using ultra-wideband? There are two approaches. I'll start with a more simple one, which is called two-way ranging. So imagine you have two devices and you exchange three messages back and forth. And from this message exchange, you measure so-called time of flight. So it measures, you know, how long the signal has traveled between the devices. And really only ultra-wideband from radio technologies is able to do that. There are, of course, some other standards for Wi-Fi, for example, but ultra-wideband has the biggest fidelity in this. And the time of flight gives you a very precise distance measurement. The example on the slide is double-sided two-way ranging, which is a technique that has been used until now. With the latest standard, there's also single-sided two-way ranging, which limits the number of messages that you need to exchange between the devices to two. So just send two messages, and from that you have a very precise distance measurement. Now, both of these scenarios gives you only the distance. If you want to XY position itself, not just the distance measurement, you need to do this kind of message exchange with at least three anchors, three fixed devices to actually have XY position. Another a little bit more complex approach, let's say, is called TDOA. And on this animation here, I'll try to explain how it works. So you have a set of anchors, which is fixed infrastructure, something like an access point. And you have tags, the locators, and those are on the objects that you're tracking. And then you have a software which kind of calculates the position as is the brain of the system. So the tag sends a signal to the anchors, they receive it. The anchors then send the timestamps to the server, which then does the position calculation. So here, the outcome is that you have actually XY coordinates, not the distance measurement anymore. Now to compare those two-way ranging versus TDOA, time difference of arrival, every one of those again has their pros and cons, but in general, two-way ranging is great for small applications, simple applications. Let's say, you know, that, tracking the key fob with the car is a very nice example. You don't need position around the car, you just need a distance to that car. So two-way ranging is perfect for that. The problem is that it's not scalable. You cannot track thousands of devices using two-way ranging. It's because of those messages that I showed you. So you have a lot of airtime. You have also limited battery on the tags. So that's where really TDOA stands out. So TDOA is what allows you to have big installations covering, let's say, whole campuses, shop floors, really having thousands of devices in the system. So it really depends on the use case where you want to use the technology. Now let's look at some of the latest news in the ultra-wideband to kind of give you an idea of where we're at today. So you may have probably heard that Apple has introduced ultra-wideband chip in their iPhones in September last year, iPhone 11 and iPhone 11 Pro. It's their own chip, their proprietary chip, so and they call it U1 chip. Right now, it's only used for AirDrop, really, where basically you have two phones, and with ultra-wideband, you can determine which phone is the right one to send files to. Apple is focusing right now mainly on the two-way ranging that I described earlier, just communication between two iPhones. They recently at the WWDC this year, they also released their SDK to actually get the location data from iPhone. So you'll probably see more applications in iPhone soon with ultra-wideband. What I'd recommend would be checking out the Wired article that they covered about the ultra-wideband chip from Apple. They kind of nicely explain like the various use cases that you can do with it. Another news is also that in August this year, I'm recording the presentation at the beginning of September, so this is like 3 weeks ago, so it's very fresh news. Samsung has integrated ultra-wideband chip into their latest Galaxy Note 20. So that's another telco giant that is right now switching to ultra-wideband. So we can see a little pattern happening here. For ultra-wideband, there are new standards that are being made. First standard was introduced back in 2007. There were some ratifications, but the biggest change is coming actually this year. And the new standard called 4Z has been approved on 25th of August, 2020. So it's very, very fresh. It brings new changes to the Mac and PHY of the ultra-wideband, and it focuses mainly on two-way ranging applications. Now, the main thing is that it really prepares the technology for massive adoption. So it increases security, battery life, and really the ability to have, huge number of tags at one place at one time without any interference. Now, the biggest standardization organizations in ultra-wideband right now are the UWB Alliance, FIRA Consortium. FIRA stands for Fine Ranging, and Car Connectivity Consortium. So these are the three main organizations that are pushing the ultra-wideband standardization forward. There are also new chips being introduced to the market, which is a very big thing. Because until recently, let's say some 2 years ago, there was really just, let's say, one or really handful of providers, and most of the technologies or the chips were really proprietary. And one of the open platforms was based on a company called Decawave, which is now acquired by Qorvo, so part of Qorvo now. New chip was released by Apple, as mentioned, in September 2019. Shortly after, NXP announced that they are launching a chip in November. And this year, STMicroelectronics announced that they want to acquire a proprietary ultra-wideband called B-Spoon in July 2020. And as mentioned, Samsung launched the ultra-wideband. It's actually using the NXP chip. This was announced in August this year. In terms of timeline, really, if you look back, the ultra-wideband was first approved by the FCC for unlicensed use back in 2002. First IEEE standards followed in 2007. First open chip, this was a big milestone for the industry, came in 2013, where the first open chip from the company Decawave was released. In 2018, Ultra-Wideband Alliance was formed. 2019, FIRA is formed. Apple introduces Ultra-Wideband. NXP comes to the market. And this year, Decawave was acquired by Qorvo, by their mobile unit. Samsung adopts ultra-wideband, and STMicro plans to acquire ultra-wideband. So as you can see, in the last 2 years, things are, getting pretty packed with the news about ultra-wideband. So I believe right now we're, let's say, in the middle of the year. So I think we'll have a couple more announcements this year, and even more to come the year and the next one. In comparison to Wi-Fi, this is data from Ultra-Wideband Alliance. This kind of shows how long it took from first standardization or from kind of a first approval to actually introducing the technology in a consumer device. Here, the example is iPhone 3G back in 2008, where it first started to use Wi-Fi, and with Ultra-Wideband, it took a shorter amount of period to actually get it to consumer device, which is the iPhone 11. So just kind of summary to comparing the ultra-wideband to Wi-Fi. And in the near future, what we can expect is, this is again from the Ultra-Wideband Alliance projections, you can see a huge increase of ultra-wideband chips in the market, primarily in the smartphone vertical. So as you can see on the bar graph, the smartphones really take the biggest portion, including smartphone accessories. So after Apple and Samsung, we can expect that many more will follow very, very shortly with adoption of ultra-wideband. Now, this was the theoretical part. Now let's look into the practical stuff. So how to actually deliver an ultra-wideband projects. Now, in the second half, I'll talk primarily about TDOA because that's what I have the most experience with. I cannot talk about two-way ranging, unfortunately, but I hope that you guys will like it because it's very much similar to Wi-Fi, in my opinion. So the project flow in general, it has several parts. First part, and I'd say the most important one, that's why I also have it in bold writing, is to really understand the customer's needs and requirements, why he actually needs real-time tracking and how it solves his problem. So we really need to understand the customer's process and how ultra-wideband will help him to improve efficiency or increase safety or basically whatever. Next step is planning the infrastructure, basically cables, planning the tag placement. It's a very crucial part. We'll look into that later as well. Preparation of infrastructure, which means pulling the cables, preparing the switches, physical installation of anchors and tags, and then software tuning, which is the final step. On the right side, you can see some examples from our projects in the past. And you can see that it took us into some the technology took us into some very interesting places over the time. Anchor planning. So this is step number one. We use planning tools to actually estimate the performance based on a floor plan. So acquire a floor plan from the customer side and anchors, similar to, I'd say, Ekahau planning tools. But in this case, you're not really interested in connectivity and signal coverage. You're really interested in the precision. So what is mainly evaluated is so-called DOP, delusion of precision. That's, for example, parameter the GPS uses as well to select the best satellites for position calculation. And the colors kind of indicate if the precision is good or not. This is a great tool to kind of estimate the ultra-wideband performance even without the site survey. This is an example from one project, how it may look like. So the green color, obviously, it means high precision, high fidelity. Yellow means that there may be, the accuracy will be dropped a little bit, and red color means simply that you won't be getting that high accuracy. Typically, the best accuracy is achieved within the anchors. So let's say you have 4 of them. So in the area, you'll have the best accuracy. And as you physically move away from the anchors, the accuracy drops significantly. So there will experience the blind spots and the red color. Now, once you have the anchor planning done, it's time to actually physically install them. Very similar to installing a Wi-Fi access point. You want good visibility, good line of sight. You want it to be on a holder and not strapped to a metal plate or something, and for it not to be obstructed. So here's just some good examples of how it looks like in industrial plants. But at the same time, there are bad examples as well. So I know that you guys in Wi-Fi have bad Fi, so I probably imagine we'll establish something very similar for ultra-wideband soon as well. And just showing some examples here. So, just putting out the enclosure and exposing the PCB part, probably not a smart idea, especially in an outdoor environment. Slapping it on a big metal plate right next to the antenna, probably also not very good for the radiation pattern. Just leaving it hanging from the roof via a cable, also not a very good one. And we also had a customer who wanted to somehow hide the anchors, the ultra-wideband anchors, and hide them into a fake ceiling. So definitely not very good for the radio performance as well. Definitely, if you'll be installing ultra-wideband, don't do this. Don't use forks as a counterweight, as Wi-Fi ninjas have done. Definitely use proper tools. If you're not sure, you can ask UC, the troublemaker on the right side. He has some experience already with installing ultra-wideband anchors. I'm sure that he can guide you to the correct setup and tell you what you should be aware of. Now, tag placement is also a very crucial part because of the line of sight visibility. So on this example here, you can see we took this one metal trolley. We put a tag on the top side and on the bottom side. So top side has line of sight and the bottom side has absolutely no line of sight. It's covered by a sheet of metal. Now on the right side, you can see that if you have nice line of sight to the tag, you have that very high accuracy. You can see very smooth trajectory. On the bottom side, you can see that you're not losing the accuracy, but you're losing a lot of the positions. So unfortunately, what you'll experience is these drops in positioning. So this is another thing that needs to be taken into account during the design phase. And to kind of balance out the non-line of sight on the tag, what you would need to do in the example on the bottom, you would actually need to add 2 anchors into the middle to kind of compensate for the lack of line of sight that you have there. Once you have installed the anchors and placed the tags, it's all about software tweaking. Now, this process, would take a presentation itself. It's also requires a full day training. So I cannot go into much details on that because I have limited time. But what you do in the tuning, you create these so-called location cells. For example, on the picture on the right, they are kind of outlined with colors. So every color is a location cell consisting of several anchors. And yeah, then you start tracking. Simple as that. Give you some idea about implementation examples. Now, this is a technology conference, so I won't be talking about any customer names, but just to kind of give you an examples of projects. So one of the most common ones that we come across using ultra-wideband is optimizing manufacturing. So for example, tracking pallets or tracking expensive goods on the shop floor to analyze their flow, see where they're at, and automate manufacturing. It's also used to increase safety because typical project, typically in automotive, it is customary for the forklift drivers to get out of the forklift and do a lot of manual labor. And just the fact that they're getting out of the forklift is considered a safety hazard. So by automating this, you're also increasing their safety because they can stay within the forklift. They don't need to move around the shop floor to potentially get hurt. So you also eliminate manual labor and increase safety. Now, just wanted to show you a little animation of how it can look like. So as we talked about those zones, imagine you have them next to each other, and you know that given goods, for example, door, are in a given production stage, which is immediately sent into customer's ERP system, and it increases this ability to plan very accurately and to have really real-time visibility into his manufacturing process, because he didn't have that before. Optimizing a forklift fleet, also a very common use case. So imagine you have a fleet of forklifts, dozens of them, and you really want to analyze their routes, how they're going, to see if there is a way for potential optimization and also reducing bad manipulation. So for example, you know that the goods should be at this spot, but they were unloaded at the incorrect spot. So this technology, by tracking the forklifts, you know where the goods should be loaded and unloaded. So you reduce bad manipulation to basically zero. You also get valuable statistics about the forklift fleet. At the same time, you're able to identify bottlenecks. Again, simple animation that kind of shows you the idea in here for the manipulation. So tracking the forklift, by knowing where the forklift is, you know if it's picking the right pallet or the right stuff on the shop floor in real time. Now, for example, another use case is safety. Here I have mentioned oil and gas, kind of an extreme case, but it can be really safety anywhere. But oil and gas, for example, there is quite common that explosions can happen on the place, and you want to track personnel to ensure that they're safe. So imagine that if there's an explosion happening, there's a mustering point where everyone should gather in case of an emergency. And if you don't have this tracking system, this automatic tool to kind of measure who is there and who's not, you have to go one by one with the pen and paper and actually make sure everyone's accounted for. And this process can take hours. With tracking, you know immediately which people are in that safe zone and who were lost somewhere, you know their last position, so you can send a rescue team to help them. Plus, they also have a button. You can have a button on the tag so they can call for help if needed. Again, simple animation kind of demonstrating the idea. So imagine having a safe zone in some area. By tracking the personnel, you know who is in the safe zone, who's already safe, and who is left behind. You can send a rescue team to rescue him. Another example from industry, reducing search times. Imagine that you have very large shop floor where you have lots of different goods, and you need to find the right tools to continue with making the part that you're working on. But you're not really sure where it is because your colleague says he left it somewhere, but in reality it's somewhere else. So the tracking allows you to easily find search items. You can really reduce the search time from hours to really minutes, because you can look on a tablet and you know exactly, hey, this part is right here, I'm going to get it. So overall increase in the project delivery and making the whole process much easier. Now, this animation again shows very simply how it can look like. So because you're tracking your goods, your assets, you know immediately in which part of the facility this is located. And if you have hundreds of thousands of square feet, this saves you really a lot of time. Plus, it can be used again to automate a lot of the stuff. Increasing customer engagement in retail. This is kind of a different use case, but imagine you, for example, either in retail, museum, entertainment in general. Imagine you're in a museum, for example, and you're standing in front of an exhibition. And the moment you step forward before that exhibition, an audio guide starts to play, or a video, starts to play, stuff like that. So it's very useful for increasing customer engagement. Next step is also combining this virtual and augmented reality, where you can actually combine the location data with augmented reality elements that go into play. So this can be very interesting for customers. Or you can just track go-karts. It's a nice little example. So you can track all the go-karts on the track. You can compare your trajectory with your friends, and you can also increase safety, because if there's an accident on the track, for example, you can slow down the forklifts go-karts that are around that go-kart that had the accident. So that's it from me for today. If you're interested in more materials, I definitely recommend Stephen Cooper's presentation from the WLPC, the same uses presentation from the same conference. Second part is actually about ultra-wideband as well. What I'd recommend is also NXP and Samsung's content about consumer applications. Samsung has a very nice video. You have to switch to English subtitles though, which explains the consumer applications that Samsung is planning with ultra-wideband, and it's very, very interesting. The last ones are also about Ultra-Wideband Alliance, FIRA, and the task group that is in charge of making sure standardization goes through with the 4Z standard. If you'd be interested in contacting me, there are several ways. You can find me on Twitter as Mr. Ultra-Wideband, on LinkedIn, of course, or you can just send me an email. If you're interested in anything Ultra-Wideband related, I'm happy to help and discuss that with you. That's it from me for today. Thank you very much. I really hope that you liked the presentation and that you were able to learn something new. And yeah, I hope to see you next time on the next CWNP conference. Thank you.
Sadly, Peter was not able to join us live today, but I do want to address a couple of your questions. First of all, some people were asking about, is there a standard related to this range finding and so forth? And yes, a lot of this is in 802.15.4. So you can take a look in there to get some of the information. And then, of course, people add their own extra capabilities on top of this. In addition, I'd like to encourage you to visit their website. I know when we were first looking at this presentation, I said, you know, that company name sounds really familiar to me. And then I realized, oh, that's where I got my 802.15.4 sniffer from. So the reality is that they have several different tools, UWB, Open Sniffer, different things like that, that can be beneficial to people. Now, before I wrap this up, I want to say quickly, stay to the end of the day. When I close things out at the end of the day today, like we always do at our conference, I have a special announcement. And you want to make sure that you're here for that announcement. So hang on till the end of the day, and we'll be back in just a few minutes.